whole of the linear algebra, then it is easy. Linear algebra, though, I would say, is nothing when compared to modern algebra. So, am I audible to you? Please respond. Okay, so did you solve the previous year question which I told you to solve yesterday? The questions I taught you about the how to prove a set as a subspace, did you solve it? Are yaar, yes or no, at least say something. Did you solve it? Mahesh, Bhagnana and all, everyone, did you solve the questions I told you to solve previous year questions? No reply. Were you able to solve the questions that I taught you of UPSC previous years? The concept which I taught you yesterday, were you able to solve those questions? A simple question, a yes or no answer would suffice. Mahesh, Gaurav. See these things, you are not solving question would only hamper your chances of becoming civil servant. Okay, so please take this thing seriously. It would have hardly taken hour. I'm saying maximum an hour to solve those questions which I taught you yesterday. But I think you didn't solve that too. Okay, so ठीक है, I'll move ahead. Okay, if you had solved the question, then you would have asked me the questions or doubt related to it, but never mind. Okay, so moving ahead. Now see, the things are going to be a little tricky, so don't worry. Okay, I'll teach you, you will learn, but the things are going to be a bit tricky from now on. Okay, so we have a linear combination. What is a linear combination? What is a linear combination? Linear combination definition. What is the definition? The definition is such that linear combination is nothing writing an element in the form of linear combinations of other. That is, if alpha is written as a1 alpha 1 plus a2 alpha 2 plus a3 alpha 3 ... an alpha n, then we can say that alpha is linear combination of the set alpha 1 alpha 2 ... alpha n. Okay, and here a1 a2 a3 and an till an are the elements of the field, and alpha 1 alpha 2, as I already said you, that I'll use the Greek letters to showcase the elements of the vector field, vector space, sorry. So this alpha belongs to the vector space, alpha 1 alpha 2 all belong to vector space, and a1 a2 an is the scalar of the field. Also you can see that this you can also learn by yourself only. We have only defined vector addition and scalar multiplication. So a1 cannot be a vector, or alpha 1 out of these two only one would be a scalar and one would be a vector, because it is defined as a scalar multiple. Okay, we haven't defined vector multiplication. Okay, so we have a vector addition and we have a scalar multiplication. So this is the linear combination. Okay, so what is a linear span? Okay, so what do we do? Suppose I take a set S. Okay, this set is S would be a subset of the vector space. Okay, and suppose it has n element. that is alpha 2, alpha 3, dot 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 alpha n. Okay, so out of the field, if you take any n element, a1, a2, a3, an, and you make this combination, a1 alpha 1 plus a2 alpha 2, an alpha n, just the linear combination such that a1, a2 dot 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 an belongs to the field, then this is called the linear span of the set S. Okay, so linear span में बहुत सारे एलिमेंट आ जाएंगे नहीं. If you change this a1, a2, a3, an any time, you will get another element. You will get another element. You will get another element. So linear span is a set of all those elements. Okay, which is formed by the using the linear combination of the vector alpha 1, alpha 2, alpha 3 dot dot to alpha n. Okay, again I am saying this, I'll show you the definition. Let Vf be a vector space and S be a non-empty subset of V, then the linear span of S is set of all linear combination, all the linear combination, all. See this term all the linear combination. Okay, suppose this is alpha 1, alpha 2, alpha 3, alpha n, over suppose the field given is the real number. Okay, so then alpha 1 plus 2 alpha 2 plus 3 alpha 3 dot dot, this belongs to this span. Okay, alpha 1 plus alpha 2 plus alpha 3 belongs to span. Okay, alpha 1 plus 5 alpha 2 plus 7 alpha n, this belongs to this. So all those combination, linear combination, belong to this linear span. Okay, and this is called LS. Okay, so what is the definition? That all the linear combination of finite set of element of S is denoted by LS. Okay, thus we have LS is equal to this. Okay, so are you clear with the concept of linear span? If not, please say now only, because now we'll build up on this only. Now this linear span is very important for linear algebra. We will build up on this only, then only we'll understand linear independence, dependence, basis, dimension. All the things are going to be this only. Now we have to proceed, I will build over this only. So if you haven't understood it, I'll say it again, but please, if you haven't understood, please say now only, online students. And if you have understood it, please say yes, understood. See, I am saying that suppose I'll again take a space. Suppose VF is a vector space. Okay, and it has many elements. Suppose a set S, a subset of VF. S is a subset of VF, and if S be any element, say it has n element, it can have 2 elements, 3 elements, 5 elements. For generalization, in mathematics we study generalization only, so I have taken n elements. Okay, so linear combination of this linear span is a set. It is a set. And how is this set formed? This set is formed by the linear combination of this, all the linear combination. That is, suppose this is linear combination of this would be alpha 1, a1 alpha 1 plus a2 alpha 2 dot 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 an alpha n. Now you change the value of a1, a2, a3, an, anything, all those which are formed belong to this linear span. That is, suppose I want to take alpha 1 as 1, I want to take alpha 2 as 2, suppose I'm just taking it, and I want to take all the other 0, and I want to take alpha an as 6. So this would be a linear combination. Okay, again alpha 1 plus 5 alpha 5 plus 7 alpha n, This is a linear combination. So all those, in fact, alpha 1 itself belongs to linear span. Nahin? Alpha 1 will belong to this linear span. We'll take A1 as 1 and all the other element as 0. A2, A3, An 0. So all those linear combination will give an element of vector space. Nahin? See, you understand this. This is a vector. This is a scalar. A scalar product gives vector. Okay. And again, this is another vector. This is another vector. Adding these vector will only result a vector in V only, na? Because it is we have already saw that scalar multiplication and vector addition are closed. So all those elements will come from V only. Okay. So those elements which can be written as a form of linear combination of this comes under linear span. Okay. So we write it as linear span as alpha 1 plus A2 alpha 2 dot 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 An alpha n, where A1, A2, An belongs to the field. Okay. Now did you understand? Mahesh said yes. Hangnana, what is your status? Did you understand this? See, this is very important. Very important. From this only you will understand all the concept. Okay, one more thing. Does 0 belongs to this LS? Does 0 belongs to this LS? Shweta. Everyone, please write yes or no. Does 0 belongs to this LS span? The 0, what is 0? I told you 0 is not our 0. 0 is the additive identity of the vector space. Does 0 belongs to this? No, sir. Why not? Yes, 0 belongs to it. Why not? If you take A1, A2, A3, An all 0, then we have 0 belonging to this set. Okay, so 0 does belong to this set. We can take all the A1, A2, A3, An all equal to 0. Then it is 0. Okay. So moving on, this concept should be clear. Now we have a question here for you all. Okay, the question here is the linear span LS of any subset S is a vector space of a vector space V is a subspace of V generated by S. Please don't see this. I'll teach you what does it mean. For now, you see only this one till this. From here to here, you have to prove that LS, that is linear span of a vector S, of a subset S, we are given that S is a subset of V. I am asking that we have to prove that linear span is a vector space. Please try to prove this. Please try to prove this. LS is a vector space. Sorry. This is not a vector space. This is a subspace. This is a subspace of the BF. Please do this. आज तो बारिश हो रही है ना बहुत ज्यादा, अभी भी हो रही है क्या बारिश? हाँ, इसलिए नहीं आया कोई. Please solve this. And you can solve this. I taught you how to prove a set as a subspace. Okay, use that concept only whenever you have to prove that something is a subset. Things are going to get a bit tricky from here, so please be regular in the class. I am seeing that it may be due to rain here. Many of the students which are offline are not present. Okay, but for you, I would say that please be present. If you miss even one class, you will not understand the whole linear algebra. Or that is similar in the case of other subjects also. If you miss a class, then the whole build-up will not be there. And I teach, and in fact, mathematics is learned over something. Always we will build over something. So if you see, yesterday those were absent, or the newer student, those who didn't came yesterday, okay, see, they don't know what is how to prove something as a subspace. Now they will be having difficulty in understanding that how to prove LS is a subspace of VF. Okay, they will be having understanding, and those who haven't come today, they won't be understand the linear span concept. And if they are not able to understand the linear span concept, they won't be able to understand linear dependence, vectors, that is the basis and dimension also. So the whole of the linear algebra of vector space would be skipped. Then they will start learning from the matrices. So if you have left the chapter or haven't attended the class, please go through the recordings. Please go to the recordings, or you won't be able to understand anything.
Excuse me, sir.
हाँ
सर, वो एक तो मेरे पास एक्सेस नहीं है आपके लेक्चर्स का, तो इसलिए मैं ज्वाइन कर पाया, लेट ज्वाइन कर पाया था आज। और दूसरा सर, जो रिकॉर्डेड लेक्चर है वो मेरे को मिलते नहीं है।
नहीं, रिकॉर्डेड लेक्चर डिड यू आस्क फ्रॉम द क्या कहते हैं द टीम व्हिच इज हियर, टेक्निकल टीम?
सर मैंने पूछा था, एक्चुअली मेरी जो क्लासेस चल रही हैं वो श्वेता मैम की क्लासेस चल रही हैं, तो मैम के 2 जो चैप्टर्स हैं वो निकल चुके हैं, लीनियर अलजेब्रा और एनालिटिकल ज्योमेट्री। तो मैम ने कहा था कि आप 2 जो चैप्टर्स निकल चुके हैं वो सर के लेक्चर से कंप्लीट कर लो,
बट आपको वो नहीं मिल रहा। चलिए ठीक है, मैं आज आप बात करूंगा, पर अभी देखिए वीकेंड है, ठीक है, तो संडे तक में सारे आप जो रिकॉर्डिंग है वो सब देख लीजिएगा आप लोग प्लीज, ठीक है, तभी आप आगे को समझ पाइएगा। एंड
सर मेरे को ना तो मैं मतलब कोई हैंडआउट्स मिल रहे हैं ना रिकॉर्डेड लेक्चर मिल रहे हैं मुझे।
देखो हैंडआउट्स तो क्या कहते हैं अभी मिलेंगे भी नहीं, क्यों हैंडआउट्स अभी क्या ही लोगे, अभी तो तुम पहले ये कर लो, उसके बाद हैंडआउट्स तो मिल जाएंगे, वो तो सारी बुक्स तुम्हें अवेलेबल मिल जाएगी। बट रिकॉर्डेड लेक्चर का हमने कल मैम से पूछा था, तो मैम ने कहा था कि आई थिंक दे हैव द प्रॉब्लम इन, क्योंकि लेक्चर तो तुरंत अपलोड हो जाते हैं, तो मैम कह रही थी कि जैसे ही ये रिकॉर्डिंग बंद होती है, ये उसी पोर्टल पे ही चल रहा है, तो लेक्चर तो तुरंत ऑन द स्पॉट वो अपलोड हो जाते हैं। तो मैम कह रही थी कि मे बी यू आर नॉट अवेयर ऑफ डूइंग दैट, सो हम मैम से खुद बात करेंगे, एक बार तुम भी बात कर लेना मैम से। Okay, for now, see, I'll again tell you what I told. Okay, since they are solving, see, linear span is nothing. Okay, if I consider S a subset of vector space V, okay, then linear span is combination of all those linear combination. Okay, Rajesh, linear span is nothing but all the combination of linear span. That is, if I've taken alpha 1, alpha 2, alpha n, then all those combination, if I write this alpha 1 plus 2 alpha 2 plus 6 alpha n, alpha 1 plus 5 alpha 1 7 alpha n, I'm taking the field as a real number for now. Okay, suppose it is a complex number, then alpha 1 plus I alpha 5 is a member, anything with the linear combination. Here a1 a2 an are the elements of the field. Okay, so a1 alpha 1 a2 alpha 2, all those combination which are formed, okay, is called the linear span. And where a1 a2 an are the element of f. I took this 2 5 because I have taken that the field is the real numbers, for making you understand. This could be complex number, this could be anything, field could be anything. Okay, for now you understand that ls is the linear combination a1 alpha 1 a2 alpha 2 an alpha n. Okay. Yes, okay, Rajesh, is it clear?
Yes, sir.
Now the question for you all is that you have to prove that ls is a vector space generated by V. ls space is a subspace of VF. Subspace of VF. So I've given you that enough time. Now I'll solve it. Anyone able to solve this? Prove this, that it is a subspace. Anyone here? Again, please make this class not a monologue that I am saying and you are listening. Please reply. Okay, when I say are you able to solve, so you should either write yes or write no, or you should write that I'm trying, it will take time. Okay, but there should be a reply. Okay, then only this would be an interactive section. Okay, हुआ solve? हो गया? Prove हो गया? Okay, then also I'll prove it for you. See, for proving any set as a subspace, we know that what is the formula do we have? We have if alpha comma beta belongs to LS, then we have to prove A alpha plus B beta also belongs to LS. That's it na, yahi proof karna tha. So these are the tools we have. We go with the basics. We take alpha comma beta belongs to LS. Okay, and let S be the set. S set kya hoga? S be the set alpha 1 alpha 2 dot 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 alpha n. Then alpha would be what? Since it belongs to linear span, then it will be of the form a1 alpha 1 an alpha n. Nahin? And beta will be of, say, b1 alpha 1 dot 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 beta n, bn alpha n. Yahi hoga na? I've taken a1 and b1, where a1 a2 dot 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 an comma b1 bn all belongs to the field F. Okay. Okay, alpha since belongs to a linear span of S, it will be of this form only. So now we'll check the properties of A alpha plus B beta. Okay, A alpha plus B beta, where A and B are from, A or B and are from, it is needless to say it is from the field. Okay, it is from the field A and B. A and B are the element of the field. This is common sense since vector scalar multiplication is defined, vector multiplication is not defined. A cannot be a vector. Since alpha and beta are the vector, A and B have to be scalar. Then only the scalar product is defined. Scalar product and vector addition is defined. Okay, so what would be A alpha? This would be A times A1 alpha 1 plus A2 alpha 2 dot 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 AN alpha n. Okay, plus B times B1 alpha beta 1 plus B2 beta 2 dot 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 Bn beta n. Okay, so this would be, this would what be beta. This is alpha only, sorry. This is B1 times alpha 1 plus B2 times alpha 2 dot 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 Bn times alpha n. Okay, so we can write that A1 plus B1 into alpha 1 plus A2 plus B2 alpha 2 dot 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 plus AN plus BN alpha n. Nahin, coefficient agar saath le le sare. So clearly we can see that this also is a linear combination of alpha 1, alpha 2, alpha 3, alpha n, alpha n, where these belongs to the field. This belongs to the field. Since these are element of the field and field is closed under multiplication and field is closed under addition. So जोड़ घटाव करके सब आ तो field में जाएंगे. After doing the multiplication addition, all will be the element of field only. So these are the element of field and this is the linear combination of alpha 1, alpha 2, alpha n. Thus A alpha plus B beta belongs to LS. Thus LS is a subspace. ऐसे किया था ना? Is it clear, everyone? Whenever you have to prove anything as a subspace, please use this concept. Take two elements alpha and beta from that group, and then please use A alpha plus B beta also belong to that group subset. Then you can easily prove that it is a subspace. Okay, so is it clear, everyone? Please reply yes or no. Okay, so moving ahead. Okay, now not moving ahead, we have to see this concept also. Now there's a tricky concept here. Now it is saying that generated by S. They see till now it is generated by S. Now what is this means generated by S? And it is written like this only. It is C. What do you know the meaning of this? That LS is, it is written that LS is S. Okay, it is written like this, and this means that ls is generated by see, very important concept. This would help you in understanding the concept in the modern algebra of prime ideals and maximal ideals, okay, and principal ideals, those ideal concept. For now, see what is happening. What is mean by generated? It has two conditions. First condition is, if I say that a set is generated by another set, we mean that S belongs to ls. First of all, it is generated by S, then we have to show that anything. When I say, if I say that I is generated by, I is a set generated by, say, another set P. Okay, if I say I is generated by another set P, it means that P belongs to I, first of all. And the second thing which it means that, listen very carefully. The second thing it means that if any other set, say H, we take any other set H, and P also belongs to H, then this whole, if P belongs to H, then I also belongs to H. I'll repeat it once again. Suppose I say I is generated by P. The first condition is this, that P should be a subset of, if I is generated by P, then P is a subset of I. Okay. And if I take any other set, say H, any other set H, and we see that P belongs to, P is a subset of H, then I would also be a subset of H. It means that I is the smallest subset whose subset is P. Once P is a subset of any other element, the whole I would also come with it. That's the concept. Generated means, if I say that ls is generated by S, what I mean is, first of all, that S belongs to ls. A second thing which I mean is, if there exists another set, say S1, okay, not S1, I'll say W, okay, if there's any subspace or any set W and S belongs to W, then it implies that ls also belongs to W. जहां जहां S आएगा, अगर पूरा सेट आ जाएगा किसी के अंदर, सबसेट बन जाएगा किसी दूसरे सेट का, तो वहां पूरा ls भी आ जाएगा. This is ls is generated by S. Okay, this is mean by this. दो कंडीशन है. ls is generated by S. First condition is that S is a subset of ls. And second is, if S is a subset of another set W, then ls is also a subset of that W. Okay? Did you get it? Online student. Please, these things are very important. Now things are going to get a bit difficult. You should understand that it is paper of UPSC and not a joke. So you should understand this. I'm waiting for yes from everyone. Mahesh, Rajesh, I didn't see your yes. Gaurav. Okay, Gaurav said yes. Okay. So it is now we have to prove that. Now we have to prove that ls is generated by S. And this is shown by this sign. ls is equal to curly bracket S. Okay. So first of all, what we have to show? We have to show that S belongs to ls. Okay. S belongs to ls. Okay. First condition is very simple. S belongs to ls. That's it. This is not a very big. The second condition is a bit tricky one. First condition is very simple. When you see this example, you will understand it. See, I say that ls belongs to ls. Okay, we have to first show this. Okay, can you show this? It is clearly easy. Suppose S is alpha 1 dot 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 alpha n. Okay, and LS is the linear combination. Okay, so suppose if I consider any element of this, say alpha 2, if alpha 2 belong to S, then clearly alpha 2 can be written as alpha 2 can be written as 0 times alpha 1 plus 1 times alpha 2 plus 0 times alpha 3 dot 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 alpha 0 times alpha n. That means alpha 2 can be written as linear combination of these vectors alpha 1 alpha n. That means alpha 2 belongs to LS. That means S is a subset of LS. Subset proof करने के लिए हमने सिखाया था ना. I told you how to prove something is a subset. You take an element from this, a random element, and you prove that that element also belongs to the linear span. Okay, so the first condition is this only, and we have proved it. The first condition we have proved it. Okay, now we have the second condition. Now we have the second condition. See, all the alpha 1, alpha 2, alpha n will also belong to LS. ये तो हम कल ही आप लोगों को बता रहे थे. LS, it will belong to. Now there is the second condition. The second condition says that suppose W is another set. W is another set, okay, and S belongs to W. Okay, S belongs to W. It is not another set, it is another subspace. I would say subspace, not subset, generated by subspace. Okay, since LS is at this. Okay, so if S belongs to W, okay, so since W is a subspace, the scalar multiplication and vector addition would be. जिसका प्रूफ नहीं है बुक में, दिस आई एम टीचिंग यू ओनली. बुक में सीधे लिख दिया है कि LS is a generated by S. I am telling you कि if scalar multiplication and vector addition are closed in a subspace, okay, so S अगर इसके अंदर है तो जो पूरा linear combination है, the whole linear combination is what? Is nothing but a scalar multiplication and vector addition. है ना? So the whole LS would not come under this W. यही तो condition थी. If S belongs to W, then what happens? Any element alpha 1, alpha 2, alpha 3, if you write it in linear combination, and since W is a vector space, subspace, so closure of both scalar multiplication and the vector addition is defined. It is closed under both these operations. Then clearly all the element of LS would come under W. Okay, so these two are the conditions. The first condition is this, and the second condition is this. Thus, LS can be written as this. LS is generated by S. See, in the book it is just written it. It hasn't proved it, but for now, please understand this. Okay, is it clear? LS is S. LS is generated by S. Since S belongs to W and W is a subspace, so all the elements alpha 1, alpha 2, alpha n, if we write it as linear combination, then the scalar product and vector addition is, since it is closed in a subspace, so we can easily say that the whole LS would also come under W. So both the conditions are true. So LS is generated by S. Now if you have any problem, please say. And if not, please say ki we understood or clear. Clear would be very easy to type, so please write clear. Okay. Okay, I'm seeing clear from 3 of you. Yeah, Rajesh and this. Bhangnana, I am waiting for your message. Okay. So now we'll see the previous topic. Now it says that the subset S, okay, of a vector space generate or spans the entire vector space. This, that is, LS is equal to W. Okay, entire vector. This is V3 vector space. This is nothing. What is V3? It is all those X, Y, Z, where X, Y, Z belongs to real number. It says that this element generates the whole set. This generates the whole set. This is the vector space. Is it true? Yes, it is true. If you want any element, say you want A, B, C. Okay, so what do? A times 1, 0, 0 plus B times 0, 1, 0 plus C times, this will get A, B, C. Okay. Okay. So it says that linear span of S is equal to V. The whole linear span is equal to V. No, it is not true. It is true. We can write any element of V in the form of this linear combination of this set. What is LS? What is LS? LS is the linear combination of the elements of S. And we see that LS will generate every element of this. This is for your understanding. Now, how to prove this? Okay. I told you that day that if you have to prove two sets equal, you have to prove that LS is equal to V. Then the first condition which you have to prove is LS is a subset of V. Okay. So it is true or not? It will be true. Since S belongs to V, so since vector addition and scalar multiplication is closed. Okay, since vectors and scalar multiplication is closed, so all the element of LS would also belong to this V only, na? जोड़ो, घटाओ, मल्टीप्लाई कर दो, कुछ भी करो, ऐड करो, स्केलर करो, the closure property है ही है. So all those elements will belong to the parent set only, na? So we'll get LS is a subset of V. This is the first thing to prove. Whenever you have to prove two sets are equal, the first thing is to prove one is a subset of another, and then you have to prove the other is a subset of this. Now we have to prove that. And delete this. Now for the second thing, what do you have to prove? That V is a subset of LS. Okay, this can be proved. Kaise? How to prove? Basic. Do this only every time. Take any element alpha belonging to V, and we show that this alpha belongs to LS. Okay. For in this case, what is, if alpha belongs to V, alpha would be of the form X, Y, Z. Okay, and alpha can be written as X times 1, 0, 0 plus Y times 0, 1, 0 plus Z times 0, 0, 1. This is what? This is linear combination of elements of S. Thus alpha belongs to LS. Okay, so we have taken alpha belongs to V and we have proved that alpha belongs to LS. Thus that means that V is a LS. This say question 2 in the exam, you will do this only. this is equation 2, this is equation 1, and from 1 and 2, LS is equal to B. Okay, clear? Everyone, clear? Easy है? अब तक समझ में आ रहा है ना चीजों? If you have understood this much, then you will understand the whole concept. Whole of the linear algebra, then it is easy. Linear algebra, though, I would say, is nothing when compared to modern algebra. You will listen many toppers, I have heard saying this. In fact, when I used to see toppers video and when I used to study, in fact, some of them said that modern algebra chhod do. When you will study modern algebra, if you understand these concepts, then modern would be easy. But modern algebra is a difficult topic, and it is like this only. इसमें क्या ना, अब यहाँ तक खत्म, this set and all खत्म. अब धीरे धीरे हम लोग न्यूमेरिकल पार्ट तक चले जाएंगे. बस वो पूरा सब्जेक्ट ही यही है. The whole subject is this set. पूरा मॉडर्न अलजेब्रा वहीं तक चल रहा है. ओके, 3 चैप्टर ग्रुप पे है, 2 चैप्टर रिंग पे है. Okay, so is it clear? So if this is clear, then we will be moving ahead. Okay, and if this is clear, then you have to solve the theorems now by yourself. Okay, it is not possible that you practice every theorem, okay, at this level. This is not your class 10th or 12th where you understand the BPT theorem or Thales theorem and you go and solve the examination. Okay, in this case, you may not be familiar. Some books have some theorems, some books have some theorems. Mostly they have all the theorems, but some of the theorems are specific to some groups. Okay, now we have a linear sum of two subspaces. Linear sum of two subspaces. Okay, its definition is let W1 and W2 be two subspaces of vector space VF. Then the linear sum of the subspaces W1 and W2 denoted by this is the set of the sum alpha 1 plus alpha 2 such that alpha 1 belongs to itna and alpha 2 belongs to this. Okay, so consider two subspace W1 and W2. Then W1 plus W2 is nothing but all the elements of the form like this, alpha 1 and alpha 2, such that alpha 1 belongs to W1 and alpha 2 belongs to W2. Okay, all those elements. What do? You take one element from first element and second element and use the vector addition. Please, again I am saying this addition is not our addition, this is vector addition. This could be anything. For now, please understand that this is addition. I am saying this from past 3 days and again I am saying this. So W1 and W2 is what? It is alpha 1 plus alpha 2. You take one element from W1 and second element from W2 and you add those elements. And all those elements, बहुत सारे बन सकते हैं ना? अगर it has 10 elements and it has 10 elements, then how many combination can be formed? If both these set has 10 element, then how many combinations? बहुत बन जाएंगे ना, 90 तो हो ही जाएंगे. 10 इसमें से लो सबको एक-एक बनाते जाओ. Okay, so alpha 1 plus alpha 2 is a alpha 1 plus alpha 2. You take alpha from W1 and you take alpha 2 from W2, and all those set is called linear sum of two vector space. Okay, this you have understood till now. Everyone, Rajesh, Mahesh. I think one of the students left. Gaurav. Okay. So if you understood till now, then you won't be having any problem in proving this theorem. W1 and W2 are the subspaces of this. You have to prove that W1 plus W2 is a subspace of VF. First of all this. And the second thing is W1 plus W2 is generated by W1 union W2, or we have shown that L of, we know that L of S is equal to S, this S generated by S. So we can also say that L of W1 union W2 is equal to W1 plus W2. We can say that same thing. Okay, so please prove this now. If you understand the concept, you would be able to prove this. And please don't miss lectures here, please. Okay, if you miss lectures, you would be very behind. What I am not asking much from you, I'm asking from you is please attend 2 hours of classes daily. Okay, and please go and give 2 hours at home. You give 4 hours to me, and you will definitely get around 280 to 290 marks in optional minimum. This thing I'm guaranteeing you. And you can get 300, 350, that's whatever. 280, 290, 300 is fixed if you just give 2 hours here and 2 hours at home. And with consistency. If you miss even one class, you will be not able to. Gaurav, which last 2 points? About this, see, I'm just saying you that linear sum of 2 subspaces is W1 plus W2, where you take one element from W1 and another element from W2, and you use the vector addition, then the whole of those set is called linear sum of 2 space. Linear sum. This linear algebra is related to only linear addition. Is it clear, Gaurav? I'm not able to get the 2 last point. What? Repeat 2 last point. What are the 2 last point? I didn't about this topic or another topic. You have to prove that W1 is a W1 plus W2 is a subspace. Are you able to prove it? The last 2 points are the question. That is the W1 plus W2 is a subspace. You have to prove this. And the second statement is W1 plus W2 is equal to linear span of W1 union W2. See, 2 of you have done this theorem. Okay, see, you are directly now solving the theorems. Okay, if you try to understand the concept, you will easily, I myself solve a very important theorem in the examination, UPSC, direct in the examination. Gaurav, please prove W1 is W2 is a subspace. That is the easier thing. I can excuse you if you are not able to prove the second point, but the first W1 plus W2 is a subspace of VF. It is a, I would say, walk in the park. Easy thing to do. Okay, the same principle, I take alpha comma beta belonging to W1 plus W2. Okay, and from my side, if you want to read any book, you can read any book from vector space. Okay, and if you find any problem regarding it, please do ask me. Okay, within the class or after the class, please solve questions from any book. But I would say any book you can study. I would say this book. So if alpha belongs to this, then alpha will be of the form alpha 1 plus alpha 2, and beta will be of the form beta 1 plus beta 2, where alpha 1 comma beta 1 belongs to W1 and alpha 2 comma beta 2 belongs to W2. Now what do? We check A alpha plus B beta. This is equal to A times alpha 1 plus alpha 2 plus B times beta 1 plus beta 2. This is equal to A alpha 1 plus B beta 1 plus A alpha 2 plus B beta 2. Now this belongs to W1. Since W1 itself is a subspace, you can ask ma'am, you can mail me. They will provide you a channel so that you can have a conversation with me. But Okay, so don't worry about that. Okay, so this belongs to W1. Since W1 is a subspace, है ना? And this belongs to W2. So again, A alpha plus B beta is nothing but the addition of an element of W1 and W2. So A alpha plus B beta also belongs to W1 plus W2. Thus, if we have taken alpha comma beta belonging to W1 plus W2 and we have proved that A alpha plus B beta belongs to W1 plus W2. So W1 plus W2 is a subspace. Clear, Gaurav? Okay. So, how many of you were able to prove the second also? This one. See, this one is easy thing to do. This one I am asking. How many of you were able to do this? We have to show that W1, W2 linear span of, or you this also you can do this, any of those methods. How many of you were able to solve this thing? हुआ नहीं हुआ? बेसिक्स चलो, बेसिक्स पकड़ो. We have to show that W1 plus W2 is equal to L of W1 union W2. Okay, so first thing क्या किया जाए, किसको किसके अंदर दिखाया जाए? We have to show that W1, पहले ये दिखा लेते हैं, ये दिखा देते हैं. We have to show this. First of all, we show this. Okay, how do we show this? Same thing, we take an element W1 plus W2. Okay, so alpha would be of the form of, alpha will be equal to alpha 1 plus alpha 2, where alpha 1 belongs to W1 and alpha 2 belongs to W2. Okay, अब हमको क्या दिखाना है? लीनियर स्पैन ऑफ दिस. ओके, अच्छा ये बताओ कि द जीरो एलिमेंट, ये हमने बताया ये तो हर सब स्पेस में होगा, नहीं होगा. जीरो एलिमेंट जो है, द आइडेंटिटी एडिटिव आइडेंटिटी एलिमेंट वुड बी इन एवरीथिंग. ओके, सो यहां एक चीज देखो, आई से दैट, ऐसे बता, रुको, alpha belongs to W1. Okay, so alpha also belongs to W1 union W2. ठीक है, alpha नहीं, sorry, alpha 1 belongs to W1, sorry, alpha 1 belongs to W1 and alpha 1 belongs to W1 union W2. Alpha 2 belongs to W2, then alpha 2 also belongs to W1 W2. So what is this? This is not a linear combination. दिख नहीं रहा है? Huh? What is this? Alpha 1 plus alpha 2 is what? It is a linear combination of the W1 union W2. So we can say that alpha belongs to linear combination of W1 union W2. So we can say that W1 plus W2 is a subset of L of, नहीं होगा, है क्या? If alpha belongs to W1 union W2, alpha 2 belongs to W1 plus union W2, then what is W1 plus W2? This is span of this only. Okay, and this is the first point which you have to prove. Now second point which you have to prove is, ये प्रूव करना ना. तो सेम थिंग बढ़ो नाउ, अब तो सीखो, अब तो इस वाले को तो करो, इस पार्ट को तो करो. सेम थिंग, टेक एन एलिमेंट अल्फा बिलोंगिंग टू Okay, I am giving you a hint here. Okay, what do we do? We take, अच्छा, alpha 1 belongs to W1. Okay, and 0 belongs to W2. ठीक है? So can we say that alpha 1 plus 0 belongs to W1 plus W2? Or alpha belongs to W1 plus W2? Alpha 1. Similarly, 0 belongs to W1 also, and alpha 2 belongs to W2. Then 0 plus alpha 2 will belongs to W1 plus W2. That means alpha 2 also belongs to W2. Okay, so alpha 1 belongs to W1 plus W2, alpha 2 belongs to W1 plus W2. Okay, then can you say that what is this linear combination? Linear combination is closed under vector and scalar. So the whole linear combination of W1 union W2, okay, the whole linear combination of W1 will also belong into W1 plus W2 ना. इसके अंदर का जब हमें I can prove that alpha 1 belongs to W1 union W2. Okay, and I also proved that alpha 1 belongs to W1 plus W2. So the whole linear combination will also belong to this ना. इसका जो linear combination है, alpha 2 belongs to W1 union W2, the whole linear combination of this would be a part of this only ना. नहीं समझा आप लोग? Okay, you do one thing. हो गया, समझ गए? तो और okay, see what I do. Please you prove this part. देखो जिनको आ गया समझ में, सी here Shweta understood and तो नाम क्या है? Puneet understood. Okay, but some of I know won't be able to understand it. Okay, so don't worry about this. I would say that what I would suggest is I will again discuss this question tomorrow on Monday. Please remind me. Okay, because this is a very important concept. You have to learn to solve the theorem by yourself in the examination. Then only it will be able to memorize it. If you are not able to understand this, you won't be able to. So I will again solve this second part. But for now, this small part, please solve it by yourself. Please try to, those who are not able to solve, please try to solve at home. Okay? Don't worry. I'll tell you if you are not able to solve, but for now, please use your head. Okay, so leave that question. Moving ahead, now we have an important concept and an easier concept: linear dependence and linear independence of a vectors. Okay, linear dependence and linear independence of vector. See, after this linear independence, then we have basis. I think till Tuesday our syllabus would be completed for at least this part, vector space. Then we'll have linear transformation. It will take 2 or 3 days. मैट्रिसेस तो यार एक हफ्ते में हो जाएगा. A linear algebra will be finished within 10 days. Okay, so we have linear dependence and independence of vectors. What is this? What is linear dependence? Nothing. Don't get confused. What if suppose a set of vector alpha 1, ये तो पढ़े भी होगे पहले भी, नहीं? So many of you have studied this very. Yes, you can go with Sohm series outline for a linear algebra. But see, in that book, proofs of the theorems are not given in the Sohm series. Okay, for linear transformation, it is a good book, but some of the proofs are not given here. But UPSC can ask proofs. Okay, so please make sure to do proofs from other books. But overall, that book is good.
सर फिर थ्योरम्स किस बुक से कवर करें?
Theorem, I would suggest modern algebra Krishna series.
ओके.
उसमें लास्ट में एक वो है वेक्टर स्पेस के चैप्टर है, उसमें से है सारे थ्योरम. हम भी उसी से बता रहे हैं, जबकि बहुत सारे ऐसे थ्योरम्स है जो कि वेक्टर उस वाली बुक में नहीं है. एक और बुक है ये वाली खन्ना भामरी एब्स्ट्रैक्ट अलजेब्रा, उसमें नहीं है. बट कृष्णा सीरीज आई थिंक out of 14 subjects of UPSC, 10 are asked from the Krishna series only. Questions of 10 subjects are from the Krishna series. So suppose S is a set with alpha 1, alpha 2, alpha n as element. Okay, and we consider a1 alpha 1 plus a2 alpha 2 dot an alpha n equal to 0. ठीक है? If a1 equal to a2 equal to dot an, these all are equal to 0, then it is linearly independent. If suppose out of this a1, a2, a3, an, even one is non-zero, then it is. If even one is not 0, then it is linearly dependent. Okay, so what do we have? Let VF be a vector space, a finite set of vector itna is set to be linearly independent if there exists a scalar, not all of them 0. Some of them may be 0. Okay, some of them एक भी अगर 0 नहीं है, I would say एक भी 0 नहीं होना चाहिए, then it is called such that a1 alpha 1, a2 alpha 2, an alpha n is equal to 0, then it is linearly dependent. And if all are 0, then it is linearly independent. Okay, जैसे हम अगर तुम्हें एग्जांपल दे, if I write a1 t square plus a2 sine of angle t. Okay, a2 sine of angle t plus a3 e to the power t 5t. a3 e to the power 5t. This is equal to 0 when I say this. Every time, for every value of t, I say this is 0. Is it possible? Is it only possible if I say this is equal to 0? Forget t. I say this is equal to 0. Okay, is it possible? Is it only possible when a1 equal to a2 equal to a3 equal to 0? कहीं ना 0 हो पाएगा, और तो कोई चांस है नहीं. There is no other chance that you can find a value a1, a2, a3 such that this is 0. Clearly, sir, I have taken such typical functions. This is a polynomial function, this is a trigonometric function, and this is an exponential function. Okay, so this is an example, but it is a very easy concept, and in examination they asked you question also. So a set is called linearly independent if you can write a1 alpha 1 plus a2 alpha 2 dot to an alpha n equal to 0, and all the a1, a2, an is equal to 0, that is linearly independent. And if even 1 is non-zero, rest may be 0, or 2 is non-zero, if at least 1 is not 0, that is linearly dependent. Okay, like you can say that if I write a1 t square plus a2 3t square, this is equal to 0. Okay, so these are linearly independent. You can find a1 and a2 which is both are not equal to 0 such that this is 0. Yeah, na? You can take a1 equal to -1 and a2 equal to 1/3, then you can get this condition. Okay, but in the examination, don't worry, examination it will ask that prove that this is linearly independent and prove that it is not linearly independent or dependent. That would be solved very easily. Okay, so are you clear with the concept of linearly independent and dependence? A very easy thing, nothing. If you can write the equation in the form a1 alpha 1 a2 alpha 2 dot dot at an alpha n equal to 0, and if every a1 a2 an is equal to 0, then it is linearly independent, and if even 1 is not 0, then it is linearly dependent. Okay, see, linearly dependence is same thing. Let Vf be a vector space is said to be linearly independent if every relation of the form is 0. Okay, for each it is 0 for each I equal to 1 to n for each. Okay, is it clear? See, is it clear or not? Please say now only, then I'll ask you then question. अगर तुम देखो, either you ask me question and if you understood it then I'll ask you questions. एक तो होना चाहिए ना. Is it clear everyone?
इसमें कोई भी a of I 0 हो सकता है या more than 1, कोई भी एक.
For independence सब 0 होंगे, सब.
ओके,
सब. और अगर डिपेंडेंट है तो एक भी नॉट 0 अगर आ गया तो डिपेंडेंट है.
ओके,
इंडिपेंडेंट के लिए सब 0 होंगे. ठीक है, अब हम सवाल पूछते हैं. तब चलो, जब तुम लोगों को क्लियर हो गया तो हमें ये बताओ, सपोज alpha 1 alpha 2 dot 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 alpha n is linearly dependent. See, हम LD लिखेंगे तो linearly dependent और LI लिखेंगे तो linearly independent. इनफैक्ट कोई एग्जाम में भी लिखते हैं, तुम गलती से एग्जाम में मत लिख देना, ये चीज बुरा मान जाएगा टीचर. ओके, सो suppose this is linearly dependent. Okay, so can I say that एक और सेटअप बोलते हैं अल्फा 1 अल्फा 2 अल्फा n, ये सारे एलिमेंट तो है ही है और इसमें और भी कुछ एलिमेंट्स है, से बीटा 1 बीटा 2 डॉट 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 बीटा m. I say this is linearly independent. Okay, this is linearly dependent and this is linearly independent. Is this statement true? True or false बताना बस, true or false. I am saying that this is linearly dependent and this is linearly independent. It is true or false? False. Okay, or false. बताओ बताओ, कुछ तो बोल दो भाई. हाँ हाँ, false. Okay, very good. See, clearly any superset, write this in your copy or please remember it if you understand it. It's a very basic thing. Any superset of a linearly dependent set is also linearly dependent. Again, if I say S is equal to alpha 1 dot 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 alpha n, now it is linearly independent. Okay, then I take a subset of it. Now I say alpha 1, alpha 2, dot 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 alpha k, where k is less than n. Okay, is linearly independent. If this is true or false? This is true or false? True. Okay, so it is true. Any subset of linearly independent set is any subset of linearly independent set is linearly independent. Okay, so every superset of a linearly dependent set is itself linearly dependent, but any subset of a linearly independent set is linearly independent. Okay, now in the vector space, we see, do you understand that this thing, this is called n tuples. N tuples. Okay, इसमें कुछ नहीं होता है. The addition is clearly this only. If I say 2, 3, 4 plus 4, 5, 6. Okay, so what do? You add this only. Okay, 6, 8, 10. Okay, और यही n में हो तो n में कर लें. This is called n tuples. Okay, so please don't take any unnecessary tension doing it. Okay, it says that in any vector space V R F. Okay, here R it is written. Okay, the system of n vectors, n होगा ये, n होगा n, E1, E2, En, okay, is linearly independent, where one is denotes the unity of the field. Okay, see, one denotes the unity of the field. Okay, so is it linearly independent? Prove it, prove this is linearly independent. I'll prove this for you, please wait. See, in any question, as I told you in the subspace, whenever you have to prove a subspace, alpha comma beta belongs to this, A alpha plus B beta also belong to that set subspace. That is subspace. Second thing which we taught is, if you have to prove two sets are equal, then you have to show one is subset of another, and then other step, this is subset of this. Okay. Third thing is, to prove something is a subset of another, you have to prove S is a subset of, suppose K, you take an element of S, general element S, and you show that it also belongs to K. Okay, so in this case, in linearly independent, now the rule is very clear. For every question it will work. What you have to do? You have to write A1 E1 plus A2 E2 dot 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 AN EN, and please equate this to 0. Okay, if you get all the A1 A2 AN is equal to 0, then it is linearly independent. If you get even one not equal to 0, even one not equal to 0, then it is linearly dependent. So in this case, what do we do? A1 1 0 0 plus A2 0 1 dot 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 AN 0 0. Okay, so what do we get here? We get A1, इधर से तो 0 ही आएगा सब में से, पहले वाले में, दूसरे में क्या आएगा? A2, तीसरे में A3 AN. This is equal to 0. Now what is this 0 here? 0 क्या है? इस केस में 0 क्या बनेगा? इस केस में 0 हम लिख देते हैं, तुम भी लिख सकते हो. It is not wrong in the examination. बट इस केस का इस वाले का 0 क्या होगा? इस वाले का 0 ये होगा ना? इस वाले का 0 तो ये ना होगा. I told you that 0 is different. 0 is additive identity of the vector space. 0 is not R0. पहले तो दिमाग से निकाल दो, प्लस माइनस 0 मल्टीप्लीकेशन 1 सब निकाल दो. 0 is additive identity of the vector space, not our 0. Okay, so this is equal to 0. Now this is equal to, say, this 0. Exam में direct 0 लिखते, but for your case I am writing this to help you understand this. So clearly we get a1 equal to a2 equal to dot 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 an equal to 0. Therefore it is linearly independent. Did you get it, everyone? Please write yes or no if you understood it. Yes. Okay, so now I have another. See, now these are the 3 questions. Okay, examine this. Please examine this. Tell me which one of the followings are linearly independent and which are not. First of all, first one. Please solve it. First is linearly dependent. Okay, Gaurav, Bhagnana. Sorry if I say your wrong names. Please don't mind it. Okay, so I'm not getting answer from you two. पहला क्या आया? डिपेंडेंट. ओके, दूसरा सबका आया. पहला लिनियरली इंडिपेंडेंट, डिपेंडेंट आ जाना चाहिए. इट इज वेरी इजी. क्लियरली कोई ऐसे तो विद टाइम तुम देख के बता दोगे कि कौन सा लिनियरली इंडिपेंडेंट है, कौन सा डिपेंडेंट है. विद टाइम you will easily show that it is linearly independent or dependent. Okay, but I want you to use the basic techniques only, because कम से कम काम में हो जाए, कम से कम कंसेप्ट से काम हो जाए, उतना अच्छा है. ज्यादा सीखोगे तो समस्या क्या हो जाती है कि फिर उन चीजों को याद भी करना है ना, सिर्फ सीखना तो है नहीं. तो व्हाट डू वी टेक? a1 212 plus a2 848 equal to 0. So we have 2a1 plus 8a2 comma a1 plus 4a2 plus 2a1 plus 8a2 equal to 0 0 0. So clearly a1 equal to minus 4a2. तो बहुत बन सकते हैं. नॉन जीरो एक नहीं 1000 बन जाएंगे. ओके, we can take suppose a2 as 1, then a1 would be minus 4. Okay, so we can choose any non-zero number such that we can write na 4 times 212 plus minus 1 times 848 equal to 0. See, we don't have all the elements 0. Okay, so Gaurav, are you getting it? Mahesh and Bhagnana, are you getting it? Okay, what about the second part? Second one also a1 120 plus a2 031 and plus a3 minus 1 0 minus 1. Second also linearly independent. Some are saying independent, some are saying dependent. क्या है? Independent. Okay, Rajesh said linearly dependent. Okay, Let me check. This is A1 minus A3 equal to comma 2A1 plus 3A2 comma A2 plus A3 इक्वल टू 0 0 0. यही आएगा ना, सही है ना कैलकुलेशन. सो कैलकुलेटिंग इट वी गेट A1 इक्वल टू A3. ओके, वी गेट 2A1 plus 3A2 equal to 0, and we have A2 plus A3 equal to 0. Okay, so A1 equal to, solving these two, A1 equal to A3 है, so we have 2A3 plus 3A2 equal to 0. From here we get A2 equal to minus A3. Okay, so 2A3 minus 3A3 equal to 0, we get A3 equal to 0, so we get A1 equal to 0, we get A2 equal to 0. All the 0, so it is linearly independent. Okay, linearly independent. What about third? Third one नहीं हो रहा है, हाँ? क्या है वो बता देना. A1 इंटू पहला क्या है वेक्टर, अच्छा नहीं की है, -1 2 1. थर्ड बताओ. अरे भाई ये क्वेश्चन आता है, if you are thinking that this is easy, then this comes in your question in your examination. Linearly independent dependent. So we get minus A1 plus 3A2 minus 5A3 comma 2A1 plus 0A2 plus 4A3 comma A1 minus A2 plus 3A3 equal to 0. क्या आया? Okay, so see, we can use another method to solve this. We have two equations. Okay, so इसको solve करना है अगर, please see, if you have done then it is fine, it is easy, you can solve it. Another thing to see is, if I write this in the matrix form, this would be -1 3 -5 2 0 3 1 -1 3 into A1 A2 A3 is equal to 0 0 0. यही सॉल्व करना ना. Anyone who got the answer of 3, it is linearly independent or dependent? एनीवन? डिपेंडेंट क्या है? A1 A2 A3 की वैल्यू anyone got the answer? Rajesh, Mahesh, Gaurav, Bhagnana, Shweta. Is this linearly independent or dependent? हाँ, इंडिपेंडेंट। क्या है वैल्यू? 0 0 0। इधर किसी की आई नहीं रही वैल्यू। अरे नहीं आ रहा तो यही लिख दो कि नॉट गेटिंग द आंसर, नॉट अंडरस्टैंडिंग इट। Independent. Okay. See, there's another method. You find the determinant of this. Okay. You find the determinant of this, and if you get the determinant to be 0. Okay. Suppose क्वेश्चन क्या था? पहला क्वेश्चन क्या था ना? इसने पहले नहीं बताया था। I want to clarity. Okay. Suppose this is the matrix. ये डिपेंडेंट आया था ना? इंडिपेंडेंट था, इंडिपेंडेंट था सेकेंड वाला। Suppose if you take the determinant of this, say second question, second क्या आया था? 0 0 0 है ना, independent था ना। Suppose you take in determinant of a matrix, we form a matrix here 1 2 0 0 3 1 minus 1 0 1। ओके, इसका मैट्रिक्स बताओ कितना आ रहा है? इसका डिटर्मिनेंट कितना आ रहा है? सॉरी, कितना आएगा? दिस वुड बी 3 minus 2 times 0 minus is plus 1, which is equal to 1, not equal to 0. So if अगर determinant is not equal to 0, it is independent. If the determinant is not equal to 0, we form a matrix, and if the determinant is not equal to 0, how to find determinant of the first one? We can't find the determinant of the first one. Not that we can't find, we can find in the higher mathematics, but for now we cannot do here, so you can't find out. You have to go with that method only. But in this case, if you form a matrix and if you get the determinant to be not equal to 0, then it is independent. And if you get the determinant equal to 0, then it is dependent. Okay, basic hai, it is basic, it is not nothing new. He is saying dependent. Mahesh, it is not dependent, it is independent. For that, for third question also, if you write this matrix, when the matrix form minus 1 2 1 3 0 minus 1 minus 4 3, okay, so you get the value minus 1 times, this is 0, this is plus 4, minus 2 times, this is 9, and this is minus 5, and plus 1 time, and this is 12. So you get minus 4, this is 4. किसका? नहीं नहीं, ये माइनस में तुम लोग इंडिपेंडेंट कैसे आ रहा है ये? थर्ड डिटर्मिनेंट इज जीरो। हाँ, तो इट शुड हैव बीन डिपेंडेंट।
सर मैट्रिक्स वाला मेथड एग्जाम में कर सकते हैं हम?
हाँ हाँ, क्यों नहीं कर सकते? अरे भाई, मैट्रिक्स मेथड है थोड़ी कुछ।
वो हर एक के लिए फॉर्म नहीं हो सकती ना मैट्रिक्स?
हाँ नहीं, हर एक के लिए नहीं हो सकती। थर्ड वाला क्या आया तुम लोग का? अगर जीरो आ रहा है तो इट इज डिपेंड, इज कमिंग जीरो, क्लियरली इट इज जीरो आ रहा है। तो महेश वॉज राइट आई थिंक। थर्ड वाले का ऐसे आंसर क्या आया? या फिर आई हैव कैलकुलेटेड रॉन्ग, calculation mistake, this is minus 5. Okay, so it is minus 1 0 0 minus plus 4. Okay, it is minus 2, this 4 plus
सर सही है, डिपेंडेंट ही आ रहा है।
डिपेंडेंट है ना? yes, it will be dependent. If the determinant is 0, then it is dependent. See, it is nothing of I won't say a rocket science. होता क्या है कि अगर तुम ax equal to 0 करते हो, okay, if you take ax equal to 0, okay, and इसका अगर डिपेंडेंट, इसका डिटर्मिनेंट अगर 0 आ जाता है, then you get the non trivial solutions. So non trivial solutions are dependent. Okay, when you will study matrices and determinant, you will understand where this concept come. But if it is equal to 0, then it is dependent. Okay. Or if it is not equal to 0, then it is independent. When you will study rank and all those things, you will understand why I am saying this. This is not some technique, it is a proper conceptual mathematics concept. Okay, so moving ahead, I have a question for you. I think this question came in the examination. This question, it says that if alpha, beta, gamma are linearly independent vectors of vectors Vf, and F is the field of complex numbers. F is a field of complex numbers. Now that the field has changed. Okay, F is a field of complex number. Then show that alpha plus beta, beta plus gamma, and gamma plus alpha is also linearly independent. Okay, please solve this question. क्या हुआ? आया? हाँ, please solve this question. Please solve this question. It says that if alpha, beta, gamma are linearly independent vectors of Vf, where F is a field of complex number, then also so are alpha, beta, alpha plus beta, beta plus gamma, and gamma plus alpha. Please go with the basic technique which I taught you. I think it is a easy question. You must be able to do this. हो गया, easy है. Okay, so first of all we have to check that this is linearly independent. Okay, so we take a1 alpha plus beta plus a2 beta plus gamma plus a3 gamma plus alpha equal to 0. Say 0. Okay, and if we get a1, okay, again see this 0 would be what? In this case 0 would be what? Vector space 0 could be 0 plus 0i. Okay, so we get, what do we get? Agar if we can find a1 is equal to a2 equal to a3 equal to 0, then we have linearly independent. So what do we have? We have a1 plus a3 into alpha plus a1 plus a2 into beta plus a2 plus a3 to gamma. This is equal to 0. Okay, why I have done this? Since it is given that alpha, beta, gamma are linearly independent. So since alpha, beta, gamma are linearly independent, then these three will be equal to 0. That is a1 plus a3 equal to 0, a2 plus a3 is equal to 0, and एक और कौन सा होगा? a1 a2 हो गया, a1 plus a2 equal to 0. Solving this we get a1 equal to a2 equal to a3 equal to 0. So we have a1 equal to a2 equal to a3 equal to 0. So it is linearly independent. Okay, so I think it is an easier question. You must be able to do it. Okay, so आगे बढ़ा जाए. Can we move forward? Is it clear till now? Now, moving ahead. Okay, please look here. Now, this is an important concept. Now, these are the theorems which you don't have to prove. Okay, but you should have a idea of these theorems, because these theorems would help in proving some other theorems which are important too for us. Okay, so the first thing is says that let V be a vector space if alpha 1, alpha 2 dot dot to alpha n are non-zero vectors. Okay, non-zero vectors, then either they are linearly independent or for some a k, alpha k, where k belongs from 2 to n, is a linear combination of preceding ones. Okay, so it says that what does it say? You have to understand the meaning of this. You don't have to solve it to prove this theorem. It says that suppose there's a group. Okay, so there's a set. Okay, suppose alpha 1, alpha 2, alpha n. Okay, so it will be either linearly independent or dependent. Or to case hai nahi. So if it is linearly independent, then well and good, no problem. If it is linearly independent, then well and good. But if it is linearly dependent, okay, if it is linearly dependent, then there is some element in between. Okay, it could be alpha n also. Okay, there is some element in between such that it can be written, say alpha k. It can be written as linear combination of the preceding ones. That is a1 alpha 1 plus a2 alpha 2 dot 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 an alpha n. Sorry, alpha a k minus 1 alpha k minus 1. Okay, it says that if it is linearly independent, then well and good, no problem. Okay, but if it is not linearly independent or it is linearly dependent, then there exists an alpha k. Alpha k could be anything. Okay, alpha k could be anything. Okay, which could be written as the preceding ones, linear combinations of the preceding ones. Okay, this is a very important theorem. Please understand this. I'll use this theorem to prove many other theorems. So if you're not getting it, please say now. It says that if it is linearly independent, then well and good. Okay, if it is linearly independent, then it is well and good, no problem. Okay, but if it is not linearly independent, if it is linearly dependent, okay, then there exists an alpha k. Okay, then there are linearly independent some alpha k. There exists some alpha k, some element which could be written as the linear combination of the preceding one. Okay, see, for example, in this case, okay, in this case, we got this as linearly dependent. Okay, so one can be written as others. Okay, that is, in this case, we can write na 8 4 8 as 2 times 2 1 2. Nahin? This is the easier thing to see, but if I see the difficult one, this one also we get dependent. Okay, so it says that at least there would be one vector which can be written as linear combination of other two vectors. Okay, so in this case, can you see, it is difficult to find out like this. So it is 3 vectors, then you can find out. If it is n vectors, it will be difficult, but this is the theorem. Okay, in this case, can you find that? Can you find that? Minus of this one. नहीं, -4 है. You get 0. 2 into first one. Okay. So this is -3 and you add 2. Okay. So he's saying that this is equal to what? 2 into -1, 2 and 1 plus -1 of -5, 4 and 3. You don't have to find this. See, is it true for every element? -2 plus 6, 3. Okay, this is +4 -4. Okay, and this is 2 and -3. Okay, we can see that if it is linearly dependent, at least one vector can be written as linear combination of others. See, okay, we get the one vector at least linear combination of other. Okay, clear concept. If you have to prove this theorem also, then what you can say is, what do we see? That if it is linearly dependent, alpha 1 alpha n, okay, then a1 alpha 1 plus a2 alpha 2, okay, an, suppose ak alpha k we take. If it is not equal to 0, then we can take this that side ना, इसको तो उस तब ले जा सकते हैं ना. If it is not equal, divide कर देंगे. So for now, you please understand that if it is linearly dependent, then one of the vector can be written as sum of the linear combination of preceding vectors. Okay, linear combination of preceding vector. And please, if you are asking this question to me, don't worry, you may ask this question. I know students. यू में आज कि भाई इसके प्रीसीडिंग तो सिर्फ यही है, ये थोड़ी है। ओके, सो डोंट वरी अबाउट, प्लीज डोंट गेट दिस कंफ्यूजन। ओके, कोई इसमें आगे पीछे नहीं है। दिस सेट इज, अच्छा अगर हम एक सेट लिखे जिसमें अल्फा बीटा गामा लिखे और दूसरा सेट लिखे जिसमें बीटा गामा अल्फा लिखे, तो क्या कोई डिफरेंस है क्या? सेट इज अ कलेक्शन ऑफ एलिमेंट्स। ओके, दैट डजंट मीन दैट यू हैव टू, so what does this show? That it is, this is a of preceding vector, linear combination of preceding vector. This preceding vector ये मैं समझो उसके पीछे वाला वेक्टर। Please don't get the wrong idea that alpha 1 alpha 2 are not an ordered elements. एक random alpha 1 alpha 2 अगर लोगे तो preceding मतलब we can take some of the elements from that. Okay, is it clear now? Rajesh, Gaurav, Shweta, is it clear? Mahesh, okay. So this is a vector. This is a theorem, one of the important theorem. Now we have another theorem. Okay, the another theorem is that's the reverse of this. It says that the set of non-zero vectors is linearly dependent if some alpha k is a linear combination of the preceding ones. It is saying the same thing. ये तो फिर easy prove करना भी. Okay, it is easy to prove also. It is saying that if any of the vector can be written as, suppose it can be written as alpha 1 dot 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 alpha k minus 1 a k minus 1 alpha k minus 1. Okay, ठीक है? So clearly it is linearly dependent. नहीं, इसको उठा के उधर लेके चले जाओ. So what do we get? Alpha k plus a1 alpha 1 dot a k minus 1 alpha k minus 1, और बाकी टर्म अगर जोड़ दिए जाए, सपोज आई राइट 0 अल्फा आगे वाले टर्म k plus 1 0 टाइम्स अल्फा n. ओके, सपोज दैट 0 भी है, वो यहां पे एक -1 है, here this is 1 is -1 and here 1 of would be, definitely it is written as in this form, 1 of would be of this one. एक ही -1 आ गया, that is sufficient. That is sufficient to show it is linearly dependent. ये तो तुम observe कर सकते. This thing you can easily observe it. Okay, so both theorems are converse of each other. One says that if it is linearly independent or dependent, then alpha k can be written as linear combination of the preceding vectors, and another is saying that if a vector, it can be written as the linear combination of the preceding vector, then the whole set is linearly dependent. Okay, okay, again the same thing, clearly same thing. It says that in a vector space, a vector b is a linear combination of vector this, then the set this is linearly dependent. Easy thing. नहीं, it says that beta is linear combination of vector this, a1 alpha 1 plus a2 alpha 2 dot 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 an alpha n, then the set beta alpha 1 alpha 2 alpha n is ld. Okay, ld. Clearly it is linearly dependent. अगर इसको 0 ले जाओ, this would be minus beta plus a1 alpha 1 plus a2 alpha 2. See, we get at least one a coefficient as -1, which is not equal to 0. So it is linearly dependent. These three theorems you have to understand it. You don't have to prove it, but please at least have the idea. Prove भी कर दोगे इस वाले को तो बहुत easily. Okay, it says that if a vector space, a vector beta is a linear combination of the set alpha 1 alpha 2 alpha n, then the set itna is linearly dependent. Okay, bas. Now this is an important concept. Please don't be absent. Okay, you will go and see the previous year question. You will find that basis and dimension के ही question आते हैं. एक subspace prove करने आता है, एक linearly independent, and this is an important chapter, basis of a vector space. Okay, basis and dimension. Find the basis and dimension. Find the basis and dimension. So please don't miss the class of Monday. It is very important class. Very, very, very important class. Okay, and please tell me till now everything is clear. Please, last time, please write clear or not clear. Everyone. Okay. Okay. So that's it for today. Okay. So from Monday we'll start basis and dimension. And for now, please solve every previous year question, the concept which we have done till now. Okay. Every previous year question till now. Whether it is of subspace, linear independence, dependence, everything. I want the whole syllabus to be completed day by day. If you are missing every day, you are losing time. And please, this will get difficult. After linear algebra, analytical geometry is difficult. Calculus is easy, but things would get difficult. Please solve previous year paper. Go home and solve previous year paper from now only. Okay? Thank you.
एक्सक्यूज मी सर।
हाँ
सर, आप डाउट्स के लिए वो बता रहे थे चैनल क्रिएट होएगा, वो क्या सिस्टम समझ में नहीं आया सर।
अरे सिस्टम तो यार हम खुद आज मैम से क्लियर करते हैं, मंडे में बता देता हूँ। ओके हाँ, बट तुम लोग यार सॉल्व तो करो पहले। कोई डाउट पूछोगे क्लास में आके पूछते कोई डाउट, मत कुछ डाउट पूछता ही नहीं है, कुछ सॉल्व ही नहीं किया। कल वाला सॉल्व किया तुमने सब स्पेस वाला?
सर मेरे को ना तो मैं उनको देख पा रहा था लेक्चर्स को, ना मैं वो देख पा रहा था कॉन्सेप्ट क्या था।
अच्छा
मेरे को लॉक कर रखा है सारे।
ओके मैं बात करता हूँ उनसे। जो देख सकते हो कम से कम प्लीज सॉल्व द प्रीवियस ईयर क्वेश्चन।
आज भी सर मैंने मैम को फोन किया था, तब मैं क्लास ज्वाइन कर पाया था 15 मिनट बाद।
ओके ठीक है, मैं बात करता हूँ, नहीं तो छूट जाएगा तुम लोग का। ठीक है, अपना फटाफट सॉल्व करते जाओ। ठीक है पुनीत, सॉल्व करो प्रीवियस ईयर क्वेश्चन। अभी करोगे 1 घंटे में हो जाएगा। ठीक है, एक दिमाग में रहेगा। और अच्छी कॉपी में करना, ऐसे मत करना जैसे क्लास में करते हो। प्लीज सॉल्व इन अ नीट नोटबुक सो दैट यू हैव द टाइम टू रिवाइज इट। ओके थैंक यू।